Hello, in this video we are going to talk about the tangent to a curve at a point A with abscissa x0 and ordinate f of x0. In order to find the equation of the tangent, in order to talk about the tangent, in fact, what is a tangent to a curve at a specific point? The point here is A with components x0 and f of x0. So the tangent, if I want to draw the tangent to the curve, to the blue curve at the point A, the tangent is the line cutting the curve at just point A, okay? And this neighborhood here, this line intersects the curve at A, only at A. So how to determine the equation of this red line? This is the tangent. So in order to find the equation of this tangent, so let us remove the tangent for now. I am going to start with this secant line. The secant line passing through point A and another point M that is H far away from point A. So the distance between point A and point M is H. So the first point A has abscissa x0, the point M has abscissa x0 plus h for a certain positive value h, okay? So the point M has components x0 plus h, f of x0 plus h, okay? So here we have x0 plus h, okay? So let me correct this. So here, this is x0 plus h, okay, plus h, okay. So point M has abscissa x0 plus h, ordinate f of x0 plus h. So this is the second point on the curve. Now if I join the 2 points A and M, we have, this will be the secant line, okay? So if I want to find the equation of this, or the slope of this secant line, how to find the slope of this line? We already know the components of the first point on the line, which is A x0 f of x0, and the second point, it is M x0 plus h f of x0 plus h. So in order to find the slope of this line, it is by definition, the slope is rise over run, the change in y over the change in x. So the change in y is f of x0 plus h minus f of x0 over the change in x, it is, if I subtract x0 plus h minus x0, so what's left is h. So this represents the slope of the secant line. Now I don't want the secant line. In fact, what we are looking for is the tangent line. So how we are going to make this secant line the tangent line? So in fact, if I move M closer and closer to point A, so the secant line is going to be the tangent line. In fact, let us see here. If I make M come closer to A, it means I'm making H goes to 0, right? Because H is the distance between A and M. So the distance between A and M is H. So making M closer to A, it means making H goes to 0. This distance, I'm making this distance 0, right? So if I move M to A, so this secant line is becoming the tangent line, right? Because this line cuts the curve at just point A. So what's happening here? If I want to find the slope of the tangent, it means here, when I'm making h goes to 0, so I'm going to A, it means h goes to 0, the secant line becomes the tangent line, right? It becomes this red line, which is the tangent line. So the slope of the tangent will be, if I find the limit of this as h approach 0, it will be f prime of x0. F prime of x0 means, or represents, the slope of the tangent line. So this is the slope of the tangent line, f prime at x0, okay? So once I have the slope of the tangent line, now we can easily find the equation of the tangent line. The equation of the tangent line is given by the point slope equation, which is y minus f of x0 equal f prime of x0 into x minus x0, and this represents the equation of the tangent line, which is the red line here. Okay, so this is the equation of the tangent line. Let's go for an application on this. So we have to memorize, okay, that the slope of the tangent line is f prime of x0. This is the slope of the tangent line, and this is the equation of the tangent line. Okay, so this is how to find the equation of the tangent line. I use this point slope equation. Let's go to an application on this. If I go to this question here, they say in this question, consider the function f of x, which is x minus 1 square plus 1. C is its curve. Find the equation of t, the tangent to c at the point of abscissa 1. So this is x0. 1 is x0. Okay. So according to the rule, what is the equation of the tangent? The equation of the tangent is y minus f of x0 equal f prime of x0 into x minus x0. Okay, so this is the equation of the tangent. Now x0, as I said, it is 1, so let's substitute. So we get y minus f of 1 equal f prime of 1 into x minus 1. Okay, so we have to find f of 1 first, then f prime of 1, in order to find the equation of the tangent. But what is f of 1? How to find f of 1? F of 1, it means in f of x here, we should substitute instead of x1. So this will be equal 1 minus 1 square plus 1, which is 1 minus 1, it is 0. So 0 square plus 1, which is 1. Remain to find f prime of 1. How to find f prime of 1? So to find f prime of 1, we need to find first f prime of x. So this is f of x. To find f prime of x, we have f prime of x. So the first term here, x minus 1 square, is of the form u square. What is the derivative of u square? The derivative of u square is 2u prime, right? So let's apply it here. So it will be 2 times x minus 1 power 1, because 2 minus 1 it's 1, times the derivative of x minus 1, which is 1. So this is f prime of x. The derivative of this one here is 0 because it is a constant, right? So this will be 2 into x minus 1. So what will be f prime of 1? F prime of 1 is equal to 2 times 1 minus 1, which is 2 times 0, which is 0. Hence, the slope of the tangent at 1 is 0, which means my tangent is a horizontal line. So this means my tangent is horizontal. What is the equation of this horizontal tangent? If I substitute in this equation here, so we get t, which is y minus f of 1, which is 1, equal f prime of 1, which is 0, into x minus 1, right? Which means 0 times anything, it is 0. So we get y minus 1 equals 0. So the equation of the tangent is y equal 1. So this is, in this case, our tangent is horizontal. Thank you. See you in the next video.